After childhood, just before puberty begins, the brain has a second period of overproduction. The prefrontal cortex sprouts new cells and new connections, creating new pathways for molding. This is followed by about a decade of pruning. All through our teenage years, weaker connections are trimmed back while stronger connections are reinforced. As a result of this thinning, the volume of the prefrontal cortex reduces by about 1% a year during the teenage years. These changes set us up for the lessons we learn on our path to becoming adult. Because these massive changes happen in brain areas required for higher reasoning and control of urges. Adolescence is a time of steep cognitive change. The dorsolateral prefrontal cortex, important for controlling impulses, is among the latest region to mature. It does not reach its adult state until the early 20s. Long before neuroscientists worked out the detail, car insurance companies notice the consequences. That's why they charge more for teen drivers. Similarly, the criminal justice system has long held this intuition. That's why the juveniles are treated differently than adults. Similarly, the criminal justice system has long held this intuition. That's why juveniles are treated differently than adults. Beyond the social awkwardness and emotional hypersensitivity, the teen brain is set up to take risks. Whether it is driving fast or sending inappropriate photos, risky behaviors are more tempting to the teen brain than to the adult brain. Much of that has to do with the way we respond to reward and incentives. As we move from childhood into adolescence, the brain shows an increasing response to rewards in area related to pleasure seeking. One such area is called the nucleus accumbens. In teens, the activity here is as high as it is in adults. But here is the important fact. Activity in the orbitofrontal cortex involved in executive decision-making, attention, and simulating future consequences is still about the same in teens as it is in children. So, a mature pleasure-seeking system coupled with an immature orbitofrontal cortex. This means teens are not only emotionally hypersensitive but also less able to control their emotions than adults. Somerville and her team have an idea why peer pressure strongly compels behavior in teens. Area involved in social consideration, such as the MPFC, are more strongly coupled to other brain regions that translate motivations into actions. This suggest might explain why teens are more likely to take risks when their friends are around. Due to changes in many brain areas involved in reward, planning, and motivation, our sense of self undergoes major changes in our teenage years. How we see the world as a teenager is the consequence of a changing brain that is right on schedule. These changes leads us to be more self-conscious, more risk-taking, more prone to peer-motivated behavior. For frustrated parents the world over, there is an important message. Who we are as a teenager is not simply the result of a choice or an attitude. It is the product of a period of intense and inevitable neural changes.